Hello and welcome to PetXI Interactive, your home to GCSE revision on the go. In this maths burst, we'll be looking at interior and exterior angles of different shapes. I am in fact so confident about how easy it is to teach this maths that I'm going to show you in a race against Tom, who has bet me that his glamorous PetXI assistant can complete a challenge before I can get this maths across to you. Over to you, Tom.
In this challenge, my glamorous assistant Pete will be attempting to pop 15 balloons whilst wearing oven gloves before you can get that maths explained.
You've got no chance. I know how weak Pete is.
So here we are, Pete looks ready, let's get this challenge started.
So, if you are like me and have often looked at the pentagon-faced clock in your Auntie Nora's house and wondered what the angles inside it all add up to, well, you're in for a right treat. So before we look at pentagons and the like, let's just revisit the basics from simpler shapes. So here we have a triangle and a kite. Hopefully you have remembered that the angles inside the triangle add up to 180 degrees, and as the kite has 4 sides, the angles inside it add up to 360 degrees. As these relate to the angles inside the shapes, we call these angles interior. Think interior decorators painting a wall inside a house. So let's increase the shape by an extra side, just like my Auntie Nora's clock. So this time we have 5 sides. One way of working out the sum of the interior angles is to split the shape up into triangles like so. Pick a corner and join that corner to all the other corners of the shape. We get 3 triangles, so this means that 3 lots of 180 are needed. This makes 540, which is the sum of the interior angles in a pentagon. This approach works for any shape, but can be a bit fiddly when a shape has a lot of sides, like my Uncle Derek's clock, which has 1,254 sides. I'm not splitting that up into triangles. So let's see if we can find a pattern. You will notice that each time we add a side, we increase the sum of angles by 180 degrees. This works, but it's not useful if you have a lot of sides like Uncle Derek's clock. So instead, let's look at how the number of sides relates to the number of triangles the shapes can be split into. The triangle had 3 sides, 1 triangle. The kite had 4 sides, 2 triangles. The pentagon has 5 sides, 3 triangles. Can you spot the connection? Hopefully you have noticed that the number of triangles is 2 less than the number of sides. This is really important. I could now find the sum of angles in my Uncle Derek's clock if I wanted to, but we will use something a bit easier. This 14-sided shape. So there are 14 sides. To work out the amount of triangles, just take 2 off, which gives us 12 triangles. To work out the sum of angles, just multiply the amount of triangles by 180. This gives 12 times 180, which makes 2,160 degrees. So, we're really ploughing through this maths. Let's get back to Tom and see how the challenge is going.
Yes, we are getting on great, Dave. Pete is popping these balloons like his life depends on it.
On we go with the maths. Okay, so that deals with interior angles. Now for exterior angles. If you think of an exterior, you should be thinking of somewhere outside, like a garden. It's the same for exterior angles. They are outside a shape. But be careful. It's easy to think the exterior angles are these, when in fact, we first need to extend the sides of the shape. And these angles are the exterior ones. Now, you will recall that the sum of interior angles changed depending on the shape. This is not the case for exterior angles. The sum of them remains the same regardless of the number of sides. The magical figure you need to remember is 360 degrees. Always 360 degrees, even on Uncle Derek's clock. A couple more important things to remember. Here's our pentagon again. Here's an interior angle and here's the exterior angle next to it. You should notice that they lie on the same line. Therefore, when combined, they make 180 degrees. One final keyword to remember is regular. Look at these 2 shapes. Can you guess which one is regular? Hopefully you will have picked this one. This is a regular shape because all the sides are the same length. By a strange coincidence, all the interior angles and all the exterior angles would be the same size too. Bonus! Okay, so let's look at another question. A builder is tiling a bathroom wall. Each tile is a regular 15-sided shape. A. What is the sum of the interior angles of a tile? And B. What is the size of each exterior angle of a tile? Right then, so for part A, we can think about the number of triangles that the 15-sided shape will be split into. Remember, there are always 2 less triangles than sides, so this would make 13 triangles. Multiplying the 13 triangles by 180 gives us our answer of 2,340 degrees. The key to part B is within the question when it describes each tile as being regular. This means that all the sides are equal, but more importantly, all the exterior angles are equal. As each tile has 15 sides, there will be 15 exterior angles. Recall that the sum of exterior angles is always 360, so splitting the 360 into 15 gives us 24 degrees. So this is our answer. Okay, we finished the maths, but has Tom managed to complete his challenge?
Well, Dave, Pete is really struggling here. I'm not sure it is possible to pop 15 balloons whilst wearing oven gloves.
So there we have it. The mysteries of your relatives' clocks shall be no more. Thank you for watching. See you again on the next exciting instalment of PetXI Interactive Maths.